Hi everyone. Let's take a look at the following example. Copy each graph of f of x and then graph and label each related function. So in part 1, you're graphing g of x, which equals to 3 times f of x. Now I'm going to use 4 different colors for the 4 different parts. So here's part 1. When you think about the mapping rule with regard to 3 times f of x, in words, this means it's a vertical stretch by a factor of 3. And in terms of the mapping rule, you're multiplying all the y values by 3. So what that means is if you go back to the original function, f of x, we're going to copy the following 3 points. And you can use that as the original point, which will be mapped into the new image. So if you look at this point right here, that's negative 2 and 4, 0, 0, and 2, 4. So again, let's write that down. Starting with negative 2, 4, 0, 0, 2, 4. Now what happens is when you map this, x remains the same. So you're going to copy negative 2, 0, and 2, just like that. For the corresponding y values, you have to multiply by 3. 3 times 4 is going to be 12. 3 times 0 is going to be 0. 4 times 3, that's going to give you 12 as well. So now we're ready to map the new function, which we call g of x, which is really just 3 times f of x. So we go to the same graph. The first point is going to be negative 2 and 12. So if you look at this carefully, the scale will go up by 2, 4, 6, 8, 10, 12. So it's going to be roughly there. Negative 2 and 12. 0, 0 remains unchanged. That's the invariant point, by the way. The point is the same from before and after. And 212 is going to be roughly there. And if you connect them, that's going to be the first case. So again, if I label this, that's going to be g of x. Now in a different color, I'm going to move on to part 2. In part 2, you're graphing f of 4x. So again, if you think about the mapping rule, let's start with the words, then we'll go straight to the mapping rule. F of 4x means it's going to be horizontally compressed by a factor of 1 divided by 4. So you're going to take x divided by 4, or you can say a quarter times x. Either case is fine, and y remains the same. So again, you go back and you use the original points. And what happens is you take these points and you map it into the new graph, which we call h of x, which is f of 4x. So again, if you plug in negative 2 divided by 4 is going to be negative half. 0 divided by 4 is going to be 0. And 2 divided by 4 is going to be half. The y values remain the same, so just copy it as is. I go back to the graph. Now notice this is a horizontal compression by a factor of 1 divided by 4. So again, it's going to be very slim here. And you can see, if you look at it, you go left by half, up by 4. 0, 0, again, that's the invariant point. You go right by half, up by 4. And again, roughly speaking, the graph would look something like that. If I label this is going to be h of x. Let's keep going. We are making progress. In part 3, we're graphing m of x, which is going to be f of 2x. Again, if you say this in words, this is going to be a horizontal compression by a factor of half. This means you can take half times x, or you can say x divided by 2. Either one is fine. Again, you grab the original points, just like we did in part 1 and part 2. And now what happens is you take all the x values and you multiply by half. Half times negative 2, that's negative 1. Half times nothing, it's going to be nothing. 2 times half is going to be 1. Again, the y values remain the same. I go back. I go left by 1 this time, up by 4. 0, 0, again, that's the invariant point. It's the same from before and after. I go right by 1, up by 4. I connect them. It's going to look, roughly speaking, something like that. Again, I label this as m of x. Again, m of x in this example is going to be f of 2x. Now, I would like you to try part 4. Press pause, go through the same algorithm, the same procedure, the same steps. When you press play again, I'll be here. All right, part 4. So the way you think about this is, again, start with the mapping rule. So f of x divided by 5 means horizontal stretch by a factor of 5. So this means you take 5 times x, y remains the same. Again, you start with the same original points. And now what happens is you take the x values, multiply it by 5. 5 times negative 2, that's negative 10. 0 times 5, that's going to be 0. 2 times 5, that's going to be 10. The y values remain the same. Again, I'm going to go left by 10 this time. So it's going to be roughly somewhere here. And I'm going to go up by 4. So it's going to be right there. 0, 0 is the same, which is the invariant point. And if I go right by 10, up by 4, and I connect them, it's going to open up. And again, we label this as r of x, where in this context, r of x is going to be f of x divided by 5. If you find this video meaningful, please consider to comment, like, share, and subscribe. I hope this makes sense.